More examples. I'm going to have a proposition. I'm going to propose the following statement. My proposition says P implies Q is equivalent to not P or Q. Memorize this. It's super important. We love this proposition. This proposition connects implication to or. So this is an important proposition. Memorize it. It shows the connection between implication or. Well, how do I prove that? Let us use, let's write down proof. Let us use the truth table. Okay, remember that in math, especially in mathematical logic, in discrete math, when you have a proposition, when you have a claim, you need to have a backup for it. What's the proof? How do I support this statement? Okay, since I'm showing that these two statements are equivalent to each other, let us use the truth table. Okay, let's see what do we have. You have two statements. It means that you have 4 combinations. Four combinations. Okay. P, Q, P then Q. This is my very first statement, compound statement. P then Q. And not P. I'm going to use a different color. Not P and not P or Q. Very good. My goal is to show that the truth values for these two, P then Q, not P or Q, they are the same. Very good. Let us begin. P true, Q true, P then Q is true. Not true is false. False or true is true. Let us move on to the next line. P true, Q false, true, then false is going to be false. Not true is false. False or false is false. So far, so good. Next row. What if my P is false, my Q is true? False, then true. Remember the definition. It is true. Now, not P. P is false, not false is true. Okay, true or true is true. And finally, the very last row. What if my first statement is false, my second statement is false? False, then false. Remember the definition, it is true. Not false is true. True or false is true. Well, well. my first statement, P then Q, it has a definition. Guys, remember, it is nothing but the definition. But this guy is the one that you just created. True, true, false, false, true, 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 true. They are exactly the same. So this is 1, this is 2. Since 1 and 2 are the same row by row, so 1 is equivalent to 2. What's the meaning of that? It means that P then Q is the same as not P or Q. What's the meaning of that? It means that when you have a statement, you can replace these instead of each other. So it means that in future examples or homework questions or exercises, wherever you have P then Q, you can replace that by not P or Q. That's the meaning of that.